Hello everyone, myself Rajkumar and I am pursuing my BTech from NIT Hamirpur, and for now I am teaching you the most fundamental and basic chapter of periodic table, that is called the basic and general trends of atomic properties in the group and also in the period. So let us understand this one by one. Periodic trends in atomic properties. Like these are the some periodic trends like ionization energy, electron affinity, atomic radius, non-metallic character, metallic character, atomic radius, electron affinity and ionization energy. So we will understand these one by one. First one is our atomic radius. Look, what is the atomic radius? A measurement of a distance from nucleus to outermost shell of an atom. Look, like this. This is our nucleus, this is the shell. Distance from this to this is called our atomic radius. So we can clearly see the trends of the atomic radius in group. In group, when we go from top to bottom, what will happen? When we go top to bottom, the size of the atom is increases because the outermost shell has increases, because the exponential increasing in the atomic number can clearly see. So when we go from top to bottom, the atomic radius is increasing, and when we go from in period left to right, the atomic radius will decreases, because the reason of decreasing atomic radius in the period going from left to right is the increasing of the attraction force from nucleus, outermost electron of the shell. Look, we can clearly see like this. This attraction force is increases when we go from left to right in period. Okay, now our second one is ionization energy. So first we should learn the definition of the ionization energy. Energy is defined as the when we pull out an electron from an outer shell of the atom in gaseous state, how much energy we require to pull out the electron from its outermost shell. Like this is a nucleus, this is shell, 2 electron, and second shell maximum 8 electrons. Okay, so when we pull out this electron, how much energy we required? This is called the ionization energy. Okay, so you can see the trends of ionization energy. Like in group, when we go from top to bottom, what will happen? Ionization energy will decreases because the size of atomic radius increases and the nucleus has the weak attraction force from outermost shell to nucleus. So this is the reason for ionization energy decreases in the group from top to bottom. Like this we can see in period, from going to left to right. Ionization energy of an atom is increases because the atomic size decreases in a period from going left to right, and ionization energy is also increases because the size is reduced and the attraction force may increase, and the attraction force increases in from nucleus to outermost shell electron. Okay, so pull out an electron from this outer shell is being difficult. This is the general trend of ionization energy in a periodic table. So the third one is electron affinity. Look, what is electron affinity? When an atom gain an electron, when we add an electron from in an atom, so what is the energy change in the atom? Okay, so this is called the electron affinity. Like this is the nucleus, this is the shell. Okay, here is the electron, like this. So when we add one more electron to this atom, like this, so how much energy? Change in an atom. So this is the calculation of energy change in an atom when we add an electron in an atom. Okay, so when we go from top to bottom in a group, what will happen? The electron affinity is decreases. Why? Size is increases from going group top to bottom, so the attraction force may be decreases from nucleus to outermost shell electron. That's why when we go from top to bottom, electron affinity may decrease because energy change is not much. Okay, so decreases. Like this, when we go from period left to right. Okay, when we go from left to right, the electron affinity may increase because atomic radius decreases. Atomic radius decreases and the attraction force between electron and nucleus is increases. So that's why when we add an electron to an atom, that is very difficult and energy must be greater. Okay, and the fourth one is electron negativity. So first we should understand what is electron negativity. Electron negativity is the ability of an atom to attract an electron for a bonding purpose. Okay, for form a chemical bond. When we go in a group from top to bottom, atomic size increases and the nucleus and the attraction force between nucleus and outermost electron is decreases. So the simple reason for the electron negativity decreasing in the group, when we go in a group from top to bottom, electron negativity is decreases because attraction force. Like shell is increases when we go from top to bottom, so attraction force of new electron and nucleus is decreases. When it's decreased, the electron negativity is also decreases. Okay, so see the trends in period. When we go in period from left to right, we know that atomic size is decreases. When atomic size decreases and another electron is coming towards the atom for a bonding purpose, nucleus attracts this electron from a high attractive forces. So that's why in a period electron negativity is increases. And we also know that fluorine highest electron negative element in the periodic table. Okay, so that's the extra information. We will see these trends and their exception in another video. So for now we were just understanding the basic and general trends of these in a periodic table, the how the trends are vary in a group from top to bottom and in a period from left to right. Okay, so the last one is our metallic character and non-metallic character. 5 number. First of all, we can see the metallic character. Okay, so what metallic character? Metallic character is defined as the lose an electron from an atom is more easily or more difficult. So if an electron is removing more easily, that's an atom having a high metallic character. So when we go from group top to bottom, so electron removal is easy because the size is increasing of the atomic radius. Atomic radius is increasing. Atomic radius increasing, that's why the nuclear attraction force is decreases. So removal of an electron is easy. So the metallic character is increasing, and from period left to right we can clearly see the metallic character will be decreasing. Group 1 elements are highly metallic characters, and in this and we can see in group 17 those are very low metallic characters, because the removal of an electron, because the fluorine has the highest electronegative element in periodic table, so removal of an electron from this is very hard to us because the high amount of energy required for this. So that's why, and we can clearly see the non-metallic character. Like metallic character is the reverse of the metallic characters. Okay, so when we go from top to bottom, the metallic non-metallic character is decreases, and in period it will increases. Okay, same logic is applied for metallic character, non-metallic character, just the reverse it. Okay, so let's take an example for different type of trends in period and group one by one. Okay, so first one for atomic radius. Okay, hydrogen, lithium, sodium and potassium. So what will be the trend? So atomic radius, like look, atomic radius is increases when we go from group top to bottom, and decreases in from period left to right. So this will increasing. And took another example, sodium, magnesium, aluminium and silicon. So it will decreasing. Okay, as simple as. Second one for ionization energy. Okay, example for ionization energy is helium, neon, argon, krypton. Okay, so ionization energy is always decreasing when we go from a group top to bottom. And for sodium, magnesium, phosphorus and sulfur, it will increase, because this is going from period left to right, the nuclear force increases, so the ionization energy is also increasing. Third one is electron affinity. Okay, so fluorine, chlorine, bromine and iodine. So we can clearly see this will follows the decreasing order. Okay, and carbon, nitrogen, oxygen and fluorine, this will follows an increasing order of electron affinity. Okay, going further for electron negativity, fluorine, chlorine, bromine, iodine. So electron negativity is decreases because the atomic size is increases. Also for sodium, magnesium, chlorine and iron. ठीक है, okay, sodium, magnesium, chlorine and iron. So this will follows the increasing. Okay, so these are the general trends. You can relate these trends from the first one, that is atomic radius. Atomic radius, we can simply see the logic of atomic radius, and these trends are followed by atomic radius. When atomic radius increasing, when atomic radius decreasing, the ionization energy increasing, ionization energy decreasing, metallic character, non-metallic character, these all depend on the atomic radius. Okay, so in the next video we will learn about the exception. Okay, as per this is chemistry, so exception is the must. Okay, so in the next video we will learn about the exception, so we will discuss about this in the next video. Okay.